Okay, in this presentation we are going to look at joint entropy calculations. So this is part of an information theory part of a discrete maths course. So here is our example. The input source to our noisy communication channel is a random variable x over three symbols a, b, and c. The output from this channel is a random variable y over the same three symbols a, b, and c. The joint distribution of these two random variables is as follows. Essentially what we have here is a table. Okay, so there's three input symbols a, b, and c. So they have varying probabilities. And for each of those three input symbols, there are three possible output symbols. Although in some cases, the probability of that occurrence is 0, but it has to be factored into our table just for the sake of completeness. Okay, so there is a probability that x equals a, and there is a 25% probability that x equals a, the input symbol is a, and the output symbol is a, and vice versa. If the input symbol is b, then there is 0 probability that the output symbol is a, but there is a 25% probability that the output symbol is c. Overall probability now, not a conditional probability. Okay, so essentially what we have to do is work with those tables just to sort of refine that table a little bit. Write down the marginal distributions of x and y, compute the marginal entropies hx and hy, and compute the joint entropy h of x and y of the two random variables. So exercise A, essentially what we do is we get our table and we calculate the row totals and the column totals. Okay, that's the marginal probabilities essentially. So the probability that y equals a is 0.25 plus 0 plus 0.125, and that gives us 0.375. Likewise, the probability that y is equal to b is 0.125, and the probability that y is equal to c is 0.125 plus 0.25 plus 0.125, and that is 0.50. So those are the row totals, and the column totals are the same. Probability of x equals a is 0.375, x equals b, that is also 0.375, and x equals c is 0.25. And you should check that the row totals and column totals equal to 1. Okay, so essentially that's it. The marginal distribution of x. So essentially what we do is just add up all the row totals and column totals. So in this case it's the column totals, which is y, and again it just for x, the column totals for x, that is 0.375, 0.375, and 0.25. Okay, so that's the answer down there at the bottom. That's essentially all we have to do. Likewise for y, that's the marginal distribution for x, and we do it for y. We get 0.375 for y equal a, 0.125 for y equal b, and 0.5 for y equal to c. Okay, now so what we have to do now is calculate the marginal entropies hx and hy. So for h of x, what we have to do is get minus the summation of pxi times log of 2 pxi. So essentially the probability for each symbol times the logarithm of that probability. Okay, so for h of x, where we have symbol a has a probability of 0.375. What we do is we multiply that probability by its logarithm. 0.375 times log to the base 2 of 0.375. That is minus 1.415. Okay, that's also the same value for x equal to b. Okay, so x equal to c, the probability of c is 0.25. So what we do there is we calculate 0.25 times logarithm of 0.25 to the base 2. That is 0.25 times minus 2. So we add it all up there together, okay, and just remind ourselves that we have a minus sign in front of our summation. That is just to make sure that we end up with a positive number at the end. So we have 0.375 times minus 1.415 times 2, okay, plus 0.25 times minus 2, essentially, when we work out all the minus signs, that should end up as 1.561 bits. Okay, that's the outcome there, okay? Moving on to the entropy of y, something similar here. For each of the symbols, we calculate the probability of the symbol and times the logarithm of that. So 0.375 times log to the base 2 of 0.375 plus 0.125 times log to the base 2 of 0.125, that's minus 3, and 0.5 times log to the base 2 of 0.5, that's minus 1. So similar enough number, well, not that similar, but we have some of the same numbers as before. So we have 0.375 times minus 1.415 plus 0.125 times minus 3 plus 0.5 times minus 1. And that should work out to be 1.4056 bits, approximately. You're sort of rounding error here. Okay. Calculate the joint entropy of the two random variables, okay? Now this actually takes the same approach again, but rather than dealing with the marginal probabilities, what we are dealing with is the joint probabilities. So we're going back to our table and looking at each of the 9 joint probabilities and calculating the entropy component for each, which is to say the probability times the log of that probability, okay? So this is a representation of the table. So essentially what we're going to do is go through the table here. I have this equation set up so it sort of is a replica of the table. So looking at the top row there, we have 0.25 times log to the base 2 of 0.25 plus 0 times log to the base 2 of 0. Now what we do in that case, when we have 0 times log to the base 2 of 0, well, the log of 0 is not defined, but we sort of take the easy approach here and just sort of say 0 times anything is 0. Okay, so we just ignore the zeros. Plus 0.125 times log to the base 2. So essentially what we're doing there is going through that table and sort of seeing what duplications we have. And in 2 cases we have a probability of 0.25. Okay, first row and middle of the bottom row. And in 4 cases, we have a probability of 0.125, okay? So this speeds up a lot of the calculations there. It is handy to sort of go through it all the same. And we're going to disregard the zeros completely, okay? So let's just go back there for a second. So we have to calculate log of 0.25 to the base 2 and log of 0.125 to the base 2. And that is minus 2 and minus 3 respectively. So essentially, this speeds up a lot when we just aggregate all the similar probabilities, okay? So we have 2 cases where the probability is 0.25. So 2 times 0.25 times 0 times minus 2. And we have 4 cases where the probability is 0.125. So 4 times 0.125 times minus 3. So removing the minus signs there because it's a little bit tricky to follow all these minus signs. You should end up with a positive number. So 2 times 0.5 plus 4 times 0.375, that is 2.5 bits. Okay, so that is our overall summary there. The marginal distribution of x, the marginal distribution of y, the marginal entropy, the marginal entry of x, h of x, and the marginal entropy h of y for y, and then we have the joint entropy there. Okay, so we'll leave it there.